difference equation. So if I look this equation, there is something, but when I move everything towards one side, just like that one here, let me highlight for you again. So you can see that I have a difference equation which involves two consecutive values, that is first order, but they are linear because there is no variable multiplying it, they are constants, so it is linear as well. But whatever be the difference equation is equal to 0. It can be expressed as equal to 0. So here we have unknowns yi plus 1, but they are equal to 0 as well. So what does this mean? What does this says? So this says that okay, if I want to compute these two relations, then this will be defined like this one. Okay, so equal to 0. So what would be the complete name of this equation is any one of them. You can take you can move all the terms in one side, it will be equal to 0 in this case. So in this case I can say this is first order linear homogeneous difference equation, because identification is important. Order will explain you when we have to write down the solution. Linear will explain you what process or method you have to apply, and homogeneous will tell you that how long the solution needs to be written down. What does this mean? I will explain in the solution procedure step. But these words must be clear to you. Let me summarize again. If if unknown variable which is a discrete in nature are involved, we call it difference equation. And the difference equation has only two states, that is the value you want to compute and the previous value. यानी difference equation के अंदर सिर्फ दो states होनी चाहिए. अगर ऐसा है, then in this case we will say that our equation is the first uh, order, and linear is constant parts multiplying with it. And for homogeneous, if we take down all the equation to the one side, whatever we are left is equal to 0 in this case. So if it is possible, then we can say that okay, this is a difference equation now, is homogeneous. Now question is, what does this mean, sir, if it is possible? For example, student, I have write down the equation like that. Let's say a new value is equal to 3 times of old value plus 9, for example. So what does this sequence say? This sequence says whenever you want to generate a sequence that satisfies this relation, it has to obey a certain rule. And rule says that whenever you take previous value, you multiply it by 3, and you have to add a constant value 9. If you do so, whatever be the number you get, it will be the new value. For example, just for understanding, so let's say assume I is 0. I is 0, that is the first value. And let's say if I have I0, what would be this equation look like? This equation look like I0 means index, it is not a value, so 0 index. So index can start from 0 as well. So 0 plus 1 equal to 3 times of y naught. We will not read it 0, in fact we call it not. So what will I get? The new value y1 in a sequence is equal to 3 times of y naught plus 9. So if I know the value of y naught, because in order to start a sequence we need some starting number. For example, it is given to you that y naught, for example, it is given to you that y naught is 2, for example, that the first member of that sequence which satisfy this relation is to be 2. Then what can you do? Y1 equal to 3 times of 2 plus 9. So you will get 6 plus 9, 15. So what does this say? It says that if you want to satisfy this discrete relation in the form of difference equation, and if you want to start from the y naught equal to 2, then the next member in this sequence, that is y1, is 15. And similarly, if you put 15 back into this equation, then you will get y2. Then you put y2 there, then you will get y3, and this sequence will be continue for long. So you can generate many numbers there. Okay, so in this case the linear homogeneous difference equation are very easy to solve. You can generate the solution, but this is only for first order case. Okay, but and also you need to know the first condition. If you remember, student, in the case of differential equation, you have order and everything is defined, but also sometimes This type of condition is given to you that you want to obtain a solution of differential equation at 1 or 2 or 0 or something. So these are the similar thing that I have imposed here. What I want to say that it is index, that is whatever be the sequence, the zero value, not value. Why not value? That is the starting value is 2. Then what would be the sequence look like? Then according to this rule, the next member of the sequence is 15. And similarly, if I continue to generate the sequence, I will get number of other solutions. So student, what's the point here? The point to explain that is, if I ask you which type of equation is this, so your answer is, sir, it is first order homogeneous constant coefficient, but it is not homogeneous. Why inhomogeneous? Why? Because if I try to gather all the unknown numbers yi plus 1 yi in a one side, I will not get 0 on the other hand side, because if I bring it all the indices needs to, all the terms that have indexes needs to be bring one side. So yi plus 1 minus 3 times of yi is 9. So we can see that it's not equal to 0. So if it's not equal to 0, it is a homogeneous, it is a first order a linear difference equation, but we will not call it homogeneous, we call it inhomogeneous. And when you have a inhomogeneous, we have a different non-homogeneous, sometimes we also call it. So non-homogeneous, then we have a different solution strategy. Okay, so keep in mind that. However, the example that I gave you on a previous slide, in that example we can see that the right hand side is equal to 0. Okay, so let me write down one more example for you. Okay, so if I have yi plus 1 equal to 9 times of yi. So one can clearly understand this is first order. Why first order? Because in the equation of discrete variables, the only two states are involved, yi, then is immediately ahead of it yi plus 1. Two states, consecutive two states are involved. So it is a first order, and it is a constant. Here coefficients are constant, so we can consider the linear, and it is a first order. Is it homogeneous or not? Yes, because if I move all this term to one side or this term to that side, we can do it. So there is no left over anything. So we can say that whatever be the answer is equal to 0. So this is homogeneous as well. And obviously yi and yi plus 1 are discrete variables. So they are basically called as discrete variables. So they are considered as a what do you call it, considered as discrete variable, so they are considered as a difference equation. Okay, so let me give one more example. So how to find the solution of these type of equations and what does this represent? So for example, student, it is, keep in mind that it is one of the simplest equation as well. It's just like a differential equation. When you have a linear first order differential equation, you can solve it easily by multiplying or integrating factor or something, you can solve it. So this is also a similar idea. The only thing is it is a discrete variable and strategy is different. We have to think in the form of a sequence. So for example, student, let's uh, let's take it like that. How to say, okay, for example, you want to invest let's say you at the for you want to invest in a certain scheme. Let's say amount that you have represented initially, amount that you have, let it is represented by y naught around 1000, okay, rupees. You have 1000 rupees and you want to invest. The investor that is has agreed to give you a profit of 5% after every year. Okay, so 5% after every year, so which means that he wants to give you return of 5%. How to compute 5%? I will explain to you. So you have a 1000 rupees and you want to invest, and we are representing as a why not. That is, this is the starting value. And after every year 5000, 5% per annum. Whenever we say annum, it means we are talking about per year. Okay, per year. So, so what does this has to do with the difference equation? Understand now, because the nature of the output is discrete. Why? And one thing, let me add further. Let's complete the question first, and then we will example question first, and then we will discuss. Why not? You want to say 5000 per annum? Let's say for a period of 5 years. Okay, कितने साल के लिए इन्वेस्ट करना चाहते हैं? For 5 years. So what happened? Let me first explain, and then I will try to connect it with the difference equation. So you are here, okay, and you have y naught amount, that is 1000. When 1 year passed, okay, so when you cover 1 year, you want to have some money. Let's call it y1. How will the y1 will obtain? Y1 is basically nothing. It is equal to the y1. It is equal to the amount that you will gain is equal to y naught plus y naught 5%. Okay, yani what I have to do, I just need to compute the 5% of y naught, because 1 year passed. After one completion of 1 year, I need 5% of y naught and add it into a y naught. So this will be my new amount after completing 1 year. This will, I from this to this, whenever I move, I will get one 1 year. So the amount that I invested should be y naught plus y naught 5%. Okay. So now the current state, whatever be the amount is, I'm not computing in data wise, but you can understand this could be easily written as like that. If I take out y naught common, so I will get 1 plus 5% of, whenever you have to obtain percent, you have to divide by 100. So it's very easy. So why not? Now student, look to this relation. What does this say? After the completion of 1 year, it says the new amount, that is after the completion of 1 year, your amount will be equal to some number, just like this number, multiply by the previous value. So the previous value in this case is why not? Have you seen that? Some number 1 plus 5%, it's at the end is just a number, is a constant number. Okay, so what I have to do, if I, what I can say, the previous value, sorry, new value is equal to the something multiplied by the previous value, something. I know that exact amount, because if we want to solve it, we can compute that amount. So for example, 1 plus 5% means 1 divided by 5. So you can find out this amount. So that will be 1 plus 1 by 20. So 1 by 20 is 0.05, and then you can compute this value. Okay, so it's not that difficult. So we, what can we have it is, we can say that whole this amount is equal to 1.05. Okay, this is a constant number, 1.05. So if it's a constant number, student, so one can clearly understand that what I am referring here, 1.05 means 1.05 means we are at a 1.05 state. So it is just, I just need to multiply 1.05 with previous value, so that I will get new value, and new value belongs to the 1 year completion. So after the completion of 1 year, now whatever amount I have, this y1. So let's continue this process. So if I continue it again, so I will go to the next year as well, this which just means second year. So it is second year completion. So whenever I complete the second year, I will get y2 amount. But question is, what what y2 means? What y2 means here? So y2 means here is that this is the amount that you will have after the completion of 2 years. But if you compute the y2, you do not need a data from y0, although you can express it like that, but you need a data from the previous state, because whatever you get at y2, that is after the completion of 2 years, is purely dependent on the last year. So in last year you have amount of 1.05 times of y0, so you need to compute that quantity. So in mathematically speaking, I can repeat this process for many times. So what I'm generating now, I am generating some discrete data. I have y0, I will get y1, and based on some logic I will get y2. Similarly this process will continue. I will get y3, which third year, end of third year I will get y4, y4. So 1 year complete, 2 year complete, 3 year complete, 4 year complete, and then I will get y5. y5 is the 5 year completion plan. So at the end of y5 I will get something amount which is the original amount that I have to get after the investment of y0 amount for a period of 5 years at a rate of 5% per annum. And this is an example of compound. Compound means that whatever you have now from based on the previous year will be reinvested in the next year. So it will continue like that. So student, main point is, what is the main point to taken from it? So if I try to explain this whole process in mathematically rather than with examples, so I can say that initially I have this situation: y1 is equal to, that is after the completion of 1 year, the value is equal to 1.05. How I can get 1.05? It is, you know that, okay, so it is just a percentage of multiply by y now. Okay, so now this is the amount after 1 year, on 1 year. Now the next year, what would be the principal amount and what will I will get? So I will get, this will become the principal, because initially at the beginning I have y0, and y0 will be computed like that and give y1. This is the amount for first year. Okay, now the for second year, if it is, these are years, then second year, that is y2, at the end of second year I must get 1.05 of y1. I can do it that y1 is equal to this, so I can express this as a y0 as well. But main point is this one, that new value is purely depending on the previous value. Okay, so number 3, if I keep it like that, y2 y3 is equal to third year ending is 1.05 of y2, because that is the principal amount for the next year. So if it is compounded, so y4, that is completion of 4 year, you will get 1.05 of y3. And similarly at the end of the where you have amount 1.05 of y 4. So at the completion of your investment time, you will get that amount y5, which is equal to that one. So if I look carefully, this is the plan when I invest y0 amount, which is 1000, for at a 5% rate for 5 years. But if I say, okay, I want to still want to spend y0 amount for 5% rate, but not for 10 years. So you can clearly understand that let's continue like that for 10 more years. We can do that. But is there any way that we can express this thing in the form of equation? Because we know that all of these data are discrete, because I have a data at the end of first year, then in between nothing happened. At the end of 31st December, let's say, I will get another data. So there is a discrete where data. I will only have y0 initially in my hand. In 1 year I will get y1, then y2, y3, y4. No information available in between, because you will not get any profit over it. So because it is invested per annum. So so is there any generic way? So if I observe correctly, I can write down it like that as well. How? yi plus 1 equal to 1.05 times of yi. So if I write it down like that, so I can clearly understand that this mathematical equation represent difference equation as yi and yi plus 1 naught, and this is also a linear. Why? Because this is constant term. Every coefficient is constant. There is no constant, but I mean to say it is constant term, and it is first order. That's the interesting part. Why it is first order? Because we can see that the new value, new year amount, next year amount is purely depending on the previous year input. So it is only depending on the previous. So it is a first order, and I can write down this equation like this as well. yi plus 1 minus 1.05 times of yi. Whenever I do that, so I will get equal to 0. So whenever this situation arises, I can see that I have taken down everything equal to 0. So this equation is also homogeneous as well. So this is a difference equation which is linear and first order and homogeneous. So I should know how to solve it. The one way is to solve it like this sequential way, where you are putting the values in a data set so that you can get your result at the end. But this is very hectic way. For example, here if it is very simple example, you have to do 5 calculations. But if let's say you are dealing with some other example in which you have to compute 10,000 times this data, so obviously you never like to compute in sequence like this one, which is possible in a first order only as well, that you want to compute one by one. It take longer time. Let's say you have to compute 10,000, so you need some relation, you need some answer. You can say that okay, for this equation yi plus 1 can be computed by using this formula, or yi can be computed by using this formula. So if you know the solution, then you can solve it for any index, because you just need to change the index. So that was the objective of this course, is this part is that finding the solution of difference equation. Difference, I'm not writing complete, difference equation. Okay, so finding the solution of that's the objective. How we can do that? Because we need some formula, that okay, that formula says if you put I equal to that, you will get the invested amount after 20 years. If you put I equal to 30, you will get the principal amount. That will tell you what would be the amount that you have after the 30 years of completion of this period. So there is no need to compute manually. Okay, so that was the objective that we are looking for. Okay, let me write down some other example as well. Okay, so this is the process. So Question, this is the theoretical understanding that you must know. I can give you one technique as well, but for just to know the order. But just to give you that example, let me write down something more. In fact, just one remarks on a previous slide and then something new. Okay, then sir, what would be the case if it is a non-homogeneous difference equation? Isn't this quite simple? If I say that okay, as a company, I try to I said that okay, if you invest in our company, you will get 5% return per annum, and plus 10 rupees bonus every year, fixed bonus every year. So whatever you invested, you will get uh, 10 year, like whatever be the percentage we agree, but whatever be the answer is, you will get 10 rupees bonus on it. So in this case, equation is not like this one, not like this one, because that equation is only saying if you want to compute new year reading, it is equal to the 5% of the previous reading. So the new amount will be the 5% of this reading. But what I'm saying, I'm offering now that if you invest, you always get, for every year, you will get 10 rupees bonus. It is a fixed bonus. It's not depending on any index. It's fixed. So if I try to bring all the index term to one side, I will never get right hand side equal to 0, because that term is 10 or 20 or 30. So in this case, the equation is called is treated as non-homogeneous difference equation. Okay, so this is also possible sometime, but we are discussing this. Okay, this is one remarks, that what is the example of non-homogeneous. You have to make sure there is some fixed value that you have to compute, or just not necessary it is always a constant number. It has to be left over something. So for example, you said that if you if you invest in our company, then you will get whatever you invest a 5% plus if plus you will get the square of the number of years you spend it with us. So for example, someone says I spent 1 year, so you will after 1 year investment you will get one square. Other says okay, you will get for 2 years of investment you will get two squares, 4 rupees. If someone you can say if you invest 3 years, for 3 years at the end of third year you will get 9 rupees because 3 9. So here it is not a constant value just like 10 in previous case, it is varying as well. But at any time when I want to compute, there is a fixed amount that left over there if I kept all the yi index term on a one side. If I take down all the term there, still some value left there based on the function. So if I try to write it down like that, yi plus 1 minus 1.05 times of yi equal to I square. So something left, it is not equal to 0 in this case. Whenever there is right hand side is not 0, we call it non-homogeneous difference equation. So it is not necessary it is always a constant number. It is possible as well, but it's not necessary always a constant. It could be a function as well depending on I or any other value. Okay, so these are the examples. So what I want to say before to in the slide is that how we know that this equation is always a first order. We came to know very easily that it depends on the previous state. But what if there is one sequence, let's it is called in mathematics it's called Fibonacci. If I don't remember it, Fibonacci sequence. Okay, what does this sequence says? If you start from let's say this sequence is like that. If you start from let's say uh, 1 0 or 1, for example 0 and 1 are the two terms. it, so this is you can 0 is a number and then 1, then the other number, the third number will be the sum of last two numbers. This is a rule. So if I sum these two, I will get 1 as well. Okay, and now if I sum these two, so in order to get the fourth sequence, that will be a 2. And if I sum these two, 2 plus 1 is 3, 3 plus 2 is 5. Okay, and 5 plus 3 is 8, 8 plus 3 is 13, and so on. So what is the rule? To generate any starting from 0 and 1, or you can assume any other two starting numbers. The rule is the third number is the sum of the previous two values. So if these two numbers are considered, then this number is a sum of the previous value, immediately previous values. If this number, if these three are considered, then this is the sum of the last two numbers. And similarly, the pattern will repeat to infinite. So this is called Fibonacci sequence, or sometimes we sum them, so we call it series as well. So question is, what does this equation represent? If I try to find out what does this says, so in this case we cannot only express our relation based on the term and the previous term. We need information from the three terms, three consecutive terms. Why? Because rule says this term is obtained by the sum of last two previous two. If this is the 3, this is obtained by the previous two values, consecutive but previously two. I mean, these are the values as well. We cannot count previous two but consecutive immediately after that. So in this way, we can write down this thing is like that. If there is a rule, then what does the rule say? The rule is saying if there is a value, any value, let's say yi, then the immediate after we have yi plus 1, and then after we have yi plus 2. Okay, so we can express this in a different ways. I am using the index I plus 1, I plus 2 because I found that the student feel comfortable with these indices. I can use much more complicated index as well, but this is the index. Okay, so three consecutive values. Now try to express this in a Fibonacci sequence concept. So according to the concept, it says if these are the three consecutive values and this is the latest value, last value like this one, so this must be equal to the sum of the last two values. So if I try to write down in the form of equation, I will get yi plus 2, which is the latest value, must be equal to the sum of the last two consecutive values. So this is the equation here. Is it a difference equation? Yes, because yi plus 1, yi plus 2 could be any value here. For example, if I am considering these three numbers, so I will call this values I naught. I has a value 0 here, I1 and I2, which means that if I want to generate, if I put I naught here, so I will get y naught, y1, sorry, y naught, y1 equal to y2, and that's true as well, because if I label my data in general, so this is in our case y0, this is the first value, this is y1, and this is y2, this is y3, this is y4, y5, and so on. So index, in terms of index, so what does this say? This say, if I try to, these are the values, but in symbols it means that I want to say y2, which is this value, is equal to the sum of these two values. Similarly, what does I want to say? Y3 is a sum which has a value 2, is the sum of the last two values, that is y1 and y2, not y0. Sequence. So this represents Fibonacci sequence in the sense of difference equation. But question is, okay, this is a difference equation, no doubt about anymore, because it has a discrete variables and some differences in the sense. But question is it a first order or not? Because we have learned that for first order there is a rule. A rule says that the new value, that is latest value that you want to compute, is purely dependent on the previous value. For example, if I remove this term from it, imagine for a while this term is not present. So what I am trying to say, yi plus 2 is purely dependent on the previous value. So in this case, I can say that it is a first order. But here it's not like that. To express this rule of Fibonacci sequence, I need three consecutive values. So I cannot say that previous value. Here, if I have to explain Fibonacci series, I have to say that yi plus 2 value, that is a value which is 2 units ahead of yi, can be computed by using this rule, that it needs information from the previous value immediately. If it is I plus 2, the immediate value previously is I plus 1, and then further immediate previous value is yi. So if I want to compute information of y2, I need information of y1 and y0 as well. So this is our scheme. This is our idea. So in this case, I cannot say it is a first order. In fact, it is depending on more than one states. So is there any general way so we can avoid this type of confusion? So the idea is quite simple. Order in difference equation, if you want to just understand how to compute it, it is very simple idea. Order is very simple strategy. What you have to do, you have to look for the highest index in this equation. So highest index of y is yi plus 2. Note it down. Okay. And then look for the lowest index of y values. So the lowest index, if yi plus 2 is this, then the lowest index is yi, because yi is the lowest index, and in lowest index you add something, you will get I plus 1 index, and if you add further something, you will get I plus 2. So the lowest one is I index, and the highest index in Fibonacci sequence is I plus 2, based on these indices that we have defined. So in this case, this is the highest index and this will be the lowest index. In order to compute the order, what you have to do, you have to compute the difference, that you have to minus the highest order from its lowest order. So whatever left is your order of the difference equation. So this is, this is second order. What I can say, the Fibonacci sequence defined based on these variables is the second order difference equation. It is second order difference equation. So it is very simple now. You can apply the same rule on the previous example as well, because in previous example the value is only dependent on the previous state. So yi plus 1 is the new value and it's equal to the older value. So the which one is the highest index? This one. Okay, note down the highest index in a rough work or somewhere. And which one is the lowest index? Obviously there is only one index, so this would be the lowest one. So minus yi. this will cancel out, you will get 1. So that means that the previous example the equation is first order. Okay, so that's the first order, but the main definition of first order is it depending on the previous state only. So here it is second order because it's depending on two values. You need two information ahead of it. So once you have understand this thing, you have a clear idea. For example, without any reason, if I write down this difference equation, why I let me rephrase the Fibonacci again for to make some confusion for the students. Why I now, student, do you think this is also a Fibonacci sequence formula? Because I told you index can be changed. Here I use index yi plus 2, and based on this, this is the definition. But now I have this indices. Is it make sense to you? Is it still a Fibonacci? We have to understand term based on the indices. What does this says? It says the ith value is equal to the sum of I minus 1 value and I plus 2 value. So we know that when we have a I value, ith index value, then the consecutive values which is exist are I minus 1 and I minus 2. What does this mean? If this is the ith value, any ith value, then the consecutive value which is beneath backside of it is I minus 1, and then further backside is I minus 2. So what can we say? What does this relation is saying? If the associated value yi is yi and yi minus 1 here, and the associated value is yi minus 2, then what this is saying is saying that yi is a sum of yi minus 1 plus yi minus 2. So this means that this is exactly similar to the Fibonacci sequence, because this third value is obtained by the sum of the last two values. So this is the same thing. It's the same Fibonacci sequence but written in a different indices. So if I apply the same definition which I learned for to order, I have to look for the lowest index. Sorry, for the highest index first. So in this case, the highest index is I, simple I, and the lowest index. So which is the lowest index here? So is I minus 2 is the lowest, because lowest means you have to go far from it, backward direction. So I is this one, then this one is relatively, it is smaller than I minus 1, but it's not so far. The value which is smaller is I minus 2. This is the minimum value. So highest value is I, reference value, and the lowest value is I minus 2 here. It's not plus 2. So in minus 2 it would be the lowest value. So I minus the lowest value. So lowest value is I minus 2. So if you solve it, you will get I minus I plus 2, and I will be cancelled out, and the final answer is 2. Okay. So the order is 2. So we can say that the order of the difference equation is still 2. It does not matter in which indices you explain or express your answer. Order remains the same. Order will not change. Okay. This is the one of the point. Okay, so we have a comprehensive idea about the order, and one thing more, it is second order. But if I move all the terms to one side, I will get 0 on the other hand side, which means that this is also homogeneous. So how I can read down the Fibonacci sequence in sense of difference equation? I will say this is second order second order homogeneous linear difference equation. Why it is linear in this case, I can still say because the coefficients are not dependent on where there is no I symbol there. It is just a constant values. But if you, in a simple words, if you do not want to confuse the linear, the only thing is sufficient at the moment is just to say it is a difference equation, constant coefficient. It is constant coefficient, homogeneous, and second order. Okay, this is second order. Order and homogeneous part is most important, which we will learn in the next part. On this topic because I dedicated this lecture for difference equation, because solution is very easy. Solution is not a rocket science. So let's move ahead. How to obtain the solution of this difference equation? But keep in mind we are discussing first homogeneous. Okay, so solution of homogeneous difference equation. Okay, that's the important part. We want to compute solution of a homogeneous difference equation. Okay, when we have this situation that we want to compute the solution of a homogeneous difference equation, first we have to understand what does this mean to compute the solution. Okay, and then we will focus on the other part. So solution means, so for example, let me take the, before to start student, I just remember I forgot to point out, around 40 or 30 seconds you can take a break. Onward, including this lecture and onward, the lecture duration has been changed now. The minimum duration for 3 credit hour course is 90 minutes, and the maximum it can goes to 120. So you can find a lecture between 90 to 120 minutes. It depends on the teacher and the requirement on the specific lecture. So this lecture will be, has to be minimum 190 minutes and more than not more than 120 minutes. So this is a new thing. So onward, whatever the lecture you will find, it will be in a similar range. So this means that if you want to take a break, you can take a break on this video after 30 minutes or something, 30 minutes, 35 minutes. I will also try to cover this topic within 100 minutes of video, not more than that. Okay. So this is very easy topic as well. The only thing you have to learn is to make sure that your learning is based on the previous knowledge of differential equation. If you learn it by symmetry, you can do it very easy. So far, only difference is discrete variable and its interpretations. Rest, working wise, is quite similar. You will learn it on this slide as well. So solution, what we have to discuss is like solution of a homogeneous difference equation. So of any order, we are not bothering for the order, strategy will remain the same. But just for understanding, first we have to understand what the solution means here. So if I copy the Fibonacci example from the back of the, just let's consider this as an example as well. Okay, so what does solution means? I plus 2 equal to yi plus 1 plus yi. These are three consecutive values which represent Fibonacci sequence. So if I identify it, I will say I can do it calculation, but rough work is enough. So I can say that this is in solution part. This is second order. This is second order. This is second order homogeneous. This is second order homogeneous uh, difference equation. Okay, linear or higher order you can add as well. The difference equation. Identification is important because identification defines the process of finding the solution. So this is the part. Now question is, before going to a solution which is very highly 2-line or 3-line solution, what does solution means here? Listen, we know that this equation is obtained by using a sequence. If you remember, let me go back. There is a sequence, or you can define any other sequence. Rule is defined like that, but there is a sequence. So whenever we say we want to solve a difference equation, so keep in mind that we want to found a formula that can generate the nth term of the sequence. Okay, the idea is to generate the nth or ith term of this sequence. That was the plan. Whenever I say I want to solve a difference equation, means I want to form the formula that can give me the nth term. For example, in the case of the investment example, if I said after 20 years you will get this profit, that amount for 5% investment per annum. So if I want to know what would be the amount, then what I have to do, I have to do it sequentially. Okay, first year this will be, then second year this will be, 10 year this, 12 this, 13 this, 14. So I have to do it manually for long sheet. But what I can do, if I have a formula, then I can put index corresponding to 20 years, I will get the answer. So that was the objective in a difference equation, that you have a discrete variable and an output, but you want to create a solution such that you can find the solution in the form of formula. So how we can do that? So our target is that to find some relation some answer of this type, that is it is represents a functional form, and if it depending on I. So if I say I want to find the Fibonacci sequence number, what would be the number at 300 place? What does it means? For example, there is a first place, second, third, fourth, fifth, sixth, seven, eight. Similarly, if I continue, there is a 300 place at the end. So I want to know which sequence, which number is lying at the third 300 position. So in this case, when I have to go to the 300 position, I should have to compute manually. But if I have a formula, I can put the corresponding index there, and I will get the answer. So that was our objective. We have to obtain something like this that represent our solution. But how we will do that? That's the standard process that you have to follow, because derivation is not included in this part. You just want to know how to solve this part, but objective must be clear. That's the main point why I'm applying this part. This methodology is important. So to obtain this, you have to write down this in a homogeneous form. That is yi plus 2 minus yi plus 1 minus yi equal to 0. So this is the difference equation that you want to solve. Now what you have to do, student, you have to do the similar process that you used to do for differential equation for homogeneous. If you remember, you form something called characteristic equations. Okay, you have to form characteristic equations. How you will do that? It is very simple. If you remember, the characteristic equation can be formed is like that. So you have to look for the order of individual term. The order of this term is second order. How? I know that this is 2, second term is there. Order of this term is 1, first order, and this is 0 order term. So how I can write down the characteristic equation? Very simple. Let's say the characteristic equation parameter, we can use anything. If you remember, let's say, let's call it some equation m. You can form the characteristic equation directly. That m variable is have a power of individual term. So here the highest term is 2. So this will get the highest power is 2 m square. Why? Because this index has a 2 minus, just like minus, and this is has a highest power 1. So this will get m. Okay, and there is no term which has an index, so we can say that I plus 0. We can write it down at I plus 0. So minus m raised to the power 0, and this is whole equal to 0. So if I solve it, I will get m square minus m minus 1 equal to 0. Okay, so this is the equation. We know that this is a correct characteristic equation, and if you remember, you try to find the root of this equation. You can use calculator or any other method. Methodology is not that important. You just need a roots. So we know that it's a second order quadratic equation. We will get two roots or two roots in this case. So how we can compute? You can compute manually. I have no solution, but you can do it, or you can factorize it. It depends on your methodology of working. So let's apply the quadratic root formula. I don't remember the answer and do not have a calculator at the moment. So there is minus b, that is 1, plus minus b square, that is 1, minus 4a. What is a here? Is 1, and c is this quantity with minus sign. So minus c divided by 2a. 2a is 1. Let me recheck. Minus b minus this is b coefficient. The final answer is equal to minus b plus minus b square. So minus b. So I made a mistake here. This is a coefficient. This is b, and this should be positive. This should be positive. Minus b into minus 1 is positive. Plus minus b square minus 4a c upon 2a. So if you compute this thing, you will get 1 plus minus root 5, 1, this is negative positive, and root 5 upon 2. Okay, so we have two roots. They are real roots in the form of surds, but they are two roots. What are these roots? M could take following values. M1 is equal to 1 plus root 5 upon 2, and 1 minus root 5 upon 2. There are two possible. They are real and distinct roots. They are not complex. They are real and distinct roots. If you solve it, you will get something in decimal is 1.66, 1.16 something, and in mathematics we used to call them golden ratios, golden coefficients. But that's not the concern. These are the real and distinct. This is m1 and this is m2. I forgot to write down. They are real root and distinct. So how to write down the solution in case of real and distinct root? We all remember is like that. So there is no need of derivation. We do not need to drive anything. We just need to write down the solution. So we have two roots, m1 and m2. How do we write down the solution? We will write down like that. Yi, that is ith term, in this case can be obtained by using the following formula. Yi equal to c1 m1 power k, sorry, not k, I, whatever with the index I. Let me write down again. Yi equal to c1, this is a constant which we have to find out for to get a particular solution. M1 I power, it is in power. If anyone can compare, and c2, let me finish first thing. M2 I. Similarly, if it is a third order, I will get three roots. I will continue like C3, C4, like this. What are M1, M2? We know that from the previous slide, these are the values of M1 and M2. So it does not matter which one you call M1 and which one you call M2. Solution is same. So we can write it down C1, M1. M1 is 1 plus root 5 upon 2. And this is whole power to certain value I, index I, plus C2, which is unknown at the moment, 1 minus root 5 upon 2, and the power is I. So this is the solution for the Fibonacci sequence. What does this mean? This is the solution for Fibonacci sequence. So this means that if I want to compute nth term or sequence, I just need to put that index. If I want to compute 10th term of the sequence, I just need to put 10 as here. But one can clearly see I cannot compute the answer unless until I know the value of C1 and C2. Now question is, why do we have C1 and C2? Before to answer that part, if you remember, then in case of differential equations, rough work again, you do not write the solution like that. You used to write the solution like that. C1 e raised to the power m1x plus C2 e raised to the power m2x. So this is one of the difference, that here we do not involve e because that is the continuous representation. Here we have moved to a discrete version, and instead of x, which is an independent variable, the work in a difference equation is carried out on the indices, that if there is no x, we just label them in the form of indices, discrete data. Okay, so keep in mind it is quite not exactly same but quite similar to each other as well. That strategy C1, C2 and e raised to the power m works. We just need to write down a solution in case of differential equations. Similar process has been adopted in a difference equation but some different notation. M1, M2, and if there are 5 roots, I will continue C3, C4, C5 with M1 power, M2 power, M3 power, M4, M5 power II. Okay, so this is the representation. Now question is, sir, we used to have C1, C2 in differential equation as well, and here we also have a C1 and a C2. So what does this means? So still, at the moment, the solution I have obtained can generate any sequence which has this characteristic, Fibonacci characteristic, that is the sum of the last two numbers equal to the new number. But question is, here sir you obtain 2 3 5 8 because you started from 0 and 1, and rule is quite clear. Do we get the same sequence if I start from let's say I said the first two numbers are 1 and 9, then according to the rule the third number is 9 plus 1 10, 10 plus 9 is 19, 19 plus 10 29. So you can note that sequence is changed, however rule is same. So it means that in order to obtain a unique sequence, you need something, so that you should know, you will get the correct answer because rule is same. Both are following the Fibonacci sequence rule. But if I start from 0 and 1, I will get this sequence. And if I start with randomly 1 and 9, I will get different sequence. Rules are same. So the question is, how our solution which I obtained is in this form can represent the exact solution. Question is this one. So in order to make sure that we will get the right sequence, we need to provide some extra information. And based on that extra information, we will compute these C1 and C2. So that C1, C2 at the moment is not defined, but they will make sure that you will get the right sequence, what you want to compute. And how do we compute this thing? Very simple. This is an extra part, but it's necessary to complete one thing, because in the next part, only change happen is if the roots are repeating, what should I do? If the roots are complex, what should I do? So it is just a way of writing the solution. It's not that difficult. So you have obtained the solution of Fibonacci sequence, because Fibonacci sequence defined here in the form of homogeneous. So in homogeneous, you just need to find the characteristic equation, and you got some roots, and you have to write down your roots, you will get the answer. If it is non-homogeneous, then we have to do something extra work as well. Okay, so this is just our Fibonacci sequence. But to know that what are the impacts of C1 and C2, so let's say, student, I want to compute a sequence which is defined earlier, this one. Okay, so how I can compute? I know that why not, that is I has a zero value when we have a zero value, and y1, that is index I, has a one value, then we have a one value. It is not necessary that I'm using 0 and 1 here because of these 0 and 1. For example, I can use the sequence here as well. Still the index is y0 and this is y1. Okay, so we know that I want to compute a Fibonacci sequence based on this formula, but that sequence must have this characteristic, is that for for y naught is 0 and y1 is 1. This is our requirement. Okay, that's an interesting requirement. We net y naught is 0 and y1. So if I impose these condition in this formula, then I will get a unique sequence. At the moment, it can generate any sequence if you provide C1 and C2 manually, and that sequence can definitely generate Fibonacci sequence. But what I want to do, I want to obtain a specific sequence which says that first value is y0 and the second value is y1, and then I have to obtain the sequence based on this formula. So how we can do that? We have to impose this condition just like differential equation we used to do, but working is slightly different. What I should do, student, if you know, this is yi, and here I have y naught, which means that I in this case will take value 0. So wherever I is there, I will put 0 in order to impose this condition. So y, if I replace I 0 in this formula, the above formula that we just obtained, we will get y naught equal to C1 1 plus root 5 upon 2 naught, that is 0. If it is an index, we call it not, but when it's used as a number, we call it just like a normal number, that power. So this is the 2 and not 0, sorry. So wherever I have, I put this. So we know that anything raised to the power 0 is 1, anything raised to the power 0 is 1, and we know that we want to impose a condition that y naught must be equal to 0, because I want to generate this sequence. So first value should be 0. So if I combine all this thing, as we know, this thing goes to 1, this thing goes to 1 because it has the power raised to 0, and this thing also equal to 0. So the final answer is this one, C1 plus C2. I am writing this part first. So C1 1, C2, this part goes to 1. So this is C1 C2 equal to 0. This because y naught is 0, y naught has a value 0. So this is one condition. But I can find the condition very easily. This equation says that C1 must be equal to minus of C2. Okay, this is the condition, that C1 must be equal to minus of C2. For example, if C2 has a value 3, then C1 is minus 3. If C2 has a value 5, then C1 must be minus 5. That was the relation, but we cannot solve it because we can put C1 C2 infinite. We want to obtain the unique solution that will generate that sequence. So I have to impose second condition as well, because in this formula I have two conditions, two unknowns, C1 and C2. So I need two conditions. First condition is imposed here, which gives a relation. Now we need second condition to impose. So in this case, I can relate I as a 1. So I have to replace I 1 everywhere. So what I'm doing it on the next slide. So I will get y1 equal to c1 1 plus root 5 upon 2 1 plus c2 1 minus root 5 upon 2 c2. Okay, so what would be this thing? And oh sorry, yeah, this is one, not. So we know that and we know that y1 we want to impose equal to 1. That's our condition. You can change it, you will generate a new sequence. So 1 equal to c1 multiplying with this whole term. Okay, so this whole term is 1 plus root 5 by 2 plus c2, and this is also raised to the power 1, so it is just like this one. Okay, now student, we have this condition, but we have to solve it. We want to compute the value of c1 and c2. So if I have to compute the value of c1 and c2, then I need to solve the system equation. One equation is this one, and the other equation is this one on the back side. So here, but this equation has a very interesting conclusion. It says that c1 can be replaced by minus c2, or c2 can be replaced by minus of c1. It's up to you. So if I can replace c1 by minus of c2 in this relation, what will I get? Solving equations having c1 and c2. So if you solve it, we have this relation that c1 is minus of c2. So what I will do, I will put, instead of c1 I will put minus of c2, then take out the common and try to find the value of c2. Or we can do it c1 as well. So minus of c2, 1 plus root 5 over 2 plus c2, 1 minus root 5 over 2. So just take out the common c2. Whatever we left is this term I am writing first, 1 minus root 5 upon 2 minus this whole term minus 1 plus root 5 upon 2, and this whole multiplying by c2. So this is the term. So if I multiply it, this terms, I can see I can cancel out 1 over half minus 1 over half, and these will be add up together. So let's see what would be the value then. So I will doing continuous working here on this side. So 1 equal to 1 by 2 minus root 5 by 2 minus 1 by 2 plus, I hope you understand, I'm just shifting the denominator, and then I will get, sorry, c2 c2. So this will be cancel out, these two are add up, this is minus, sorry, this is minus. So minus 5 by 2 minus 5 by 2, this is 2 times. So I will get minus 2 5 by 2 c2 cancel out. So for c2 I want to compute the value of c2. So c2 in this case is minus 1 over root 5. Okay, so this is how we done this. So I need to compute c1. So c1 is very simple, it is just a negative of c2. So this implies c1 equal to minus of c2. c2 is minus 1 over root 5. So c1 is 1 over root 5. So c1 is 1 over root 5. So what I have to do, I have got c1 is 1 over root 5 and c2 equal to minus 1 over root 5, and I have this formula yi equal to c1. So c1 is 1 over root 5. What I am referring, I should point out, I'm talking about this formula. Okay, so I'm putting the values of c1 and c2 so that I can get the exact formula for this particular sequence. So c1 and 1 plus root 5 upon 2 over I plus this C2 which is negative, sorry, minus 1 over root 5 times of 1 minus root 5 upon 2 whole to I. So this is the formula string. This is the sequential formula that generate any term of this sequence. Which sequence? This one. Let's verify it. If you want to verify, if I put I equal to 0, then I should get 0. If I put I equal to 1, I should get 1. And also if I put I equal to 2, I should get 1. So let's put I equal to 2 in this case and see what will we get. If you want to verify, although these are not required according to the question, we should end up here, but we want to complete this topic with one example. So if you have to compute C1 and C2, which means that you want to find a sequence that has a particular meaning, unless if you leave it here, then you have a general formula that can generate the sequence based on whatever the rule you have defined. This is a Fibonacci sequence. Answer, so rule is says the last two terms equal to the third one. That's the rule. Okay, so whenever you have to find the coefficient, you mean you want to find a particular solution specific to that condition. So this is how the you obtain. So for example, if you want to verify, just replace I equal to 2. So y2 is equal to 1 over root 5, 1 plus root 5 upon 2, 2 minus 1 over root 5, 1 minus root 5 upon 1 over root 5 upon 2 whole power 2. So if you solve it, you can do it easily. At the end, once you solve it, you will find out that everything will be cancelled out in such a way that the final answer is equal to 1, because the third term in this sequence is 1. So think about it. If I ask you to obtain the nth formula for this Fibonacci sequence, so what should changes you made? You will compute the solution exactly like that. The only change you will made here is y naught is not 0. You will put y naught equal to 1 and y1 equal to 9, and then try to obtain the new system equation and solve it, so that you will get C1 and C2 and you have to replace it. So then it will generate a sequence based on the new criteria. So this is how we have to work there. Okay. Okay, student. So this is how we have to deal with it. So this is the sequence. Now student, just to save some time, I will give you example. So student, the example that we have discussed is, in this case, the roots that we computed are real and distinct. What if we have a repeated root? So just to save time, I'm just writing down the process. It's not that difficult. Repeated root. If you have a repeated root, what does this means? Let me point it out. I'm talking about this step. This part is remain the same. When you construct the characteristic equation, you got always got root. It is third order, fourth order. The you can use calculator to obtain the roots, but roots are also possible that you will get not a real root. You will get complex root or a root that are repeating. It's also possible. So question is how to write down the solution. If roots are repeating, what does it mean? For example, there is any difference equation whose roots are repeating. Let's say m1 and m2 are same. Okay, you obtain a root and you will get that m1 and m2 are same. In this case, the solution will be written like that: yi equal to c1 m1 I. This is part is same as the distinct root case, plus c2 I times of m2 or m1, whichever, because both are same in magnitude, I. Have you got the idea? So what's new happen? We have to multiply with I to it. For example, if roots are like that one for any equation, let m1 is 3 and m2 is also 3, they are repeated. So in this case, solution will be that formula sequence will be written like that: c1 3 times of I plus c2 I times of 3 I. because we cannot use the same solution twice, so it has to be a linearly independent solution. So we will write down this thing. Okay, so this is, we have to uh, continue in this fashion. Okay, so this is how we have to deal with it, uh, this part. So C1 C2 is defined like this relation. Similarly, student, if I have any other formats or any other case, if for example in the third case, because I will provide equation that you can solve, it's not a difficult topic. Number third, if you have a complex roots, this is also possible that you get complex roots. So it is very easy in case of this sequence. For example, you get m1 equal to a plus iota b and m2 equal to a minus iota b. Keep in mind that whenever you get a roots complex, they are in a conjugate pair. So it is positive, then other one is negative with the same real sign and complex values. So how do we write down the solutions there? For example, these are the two roots. So it is very simple. The strategy is quite simple because these are complex roots, but they are two different complex roots. This is a different one, this is different one, but they all always have to appear in a conjugate pair. So what you do, you have to write it down like that. Y I see, just like the concept of the real root repeated, not repeated case. So the first one is a plus iota b raised to the power I. Acha, yeah, here we have a confusion now. Sir, what is, sir, there is a confusion now. Okay, when we have a complex root, so is I, or what is the difference of this I? So this is iota and this is our index I. So just to make it clear to you that you will not confuse the number, index is in our hand, so we can change it. We cannot change the symbol of iota, it has to be iota like that. So we will change it like this. Now we are not using I as index, we are using k as index. Okay, so we can use any value as an index. It is index variable is in our control. Plus c2 a minus iota b raised to the power k. Okay, so these are the index. So what I did, nothing, I just put the complex number just like the concept of the real roots, because this complex, it's the complex, this is also complex, but they are two different numbers. So two different numbers can be replaced in the form of sequence like that. In books you can find some other solution strategies that it is by using the Movier's theorem, they try to convert into a polar form and expand it, and this is also possible, but this is enough, this is enough for us to have a solution. And when we have a specific problem, we can convert in a polar form, and using the Movier's theorem we can expand it as much as we like. But in general solution, that's are enough for the work. So these are the complex root, how you express the complex root, and how you will represent the imaginary roots. Okay, so let me write down one example that what you do if you have, because examples can be created many, because at the end you have learned that we have to apply a root finding formula and we will get root. For example, you solve certain order difference equation and you will get following roots: m1 1, m2 2. If you understand this example, you do not need to bother for any other thing. M3, let's say 5, M4, let's say 5, and M5, let's say 2 plus 3 iota, and M6 is 2 minus 3 iota. So student, if you look carefully, I have deliberately, what does this say? First of all, the roots is 6 roots. This means the order of the difference equation is 6 as well. But here equation is not given because we are not interested in the equation. We just want to know if the roots are computed like that, how do we write down the sequence formula? So here what I deliberately try to cover too many things, that here we have a repeated distant roots as well, real, repeated, real, and complex numbers as well. So how do we write down the solution? The solution is quite simple. You have to follow the same strategy. As I know that there are complex numbers as well in a root, so I am not using the index I, I am using the index k to avoid the confusion between iota and index variable I. Okay, so you can use either variable m or n, anything. Okay, so student, the rule is quite simple. If you understand this thing, you can write down the solution for any homogeneous difference equation. Once you have a root could be real, repeated, or a complex. You have to write down the solution of this type of it. So you can do it very simple. You have to memorize for each step what would be the process for a real but not repeated roots. We know that the process is like that: c1, m1k, c2, m2k. This was the solution. Okay, keep in mind k represent index. If this part is not present, this would be the solution. Now you have write down what you have to do. You have to apply the other. Here the process is they are repeating. Okay, then what would be the process of repeating? Just forget other things. What would be the process of repeating? You just have to continue adding. Okay, plus m3, m4, they are repeating. So what should you do in this case? So what should you do in this case? You will write it down like that: m3, m4. So m3, m4, how do we handle m3, m4? It is quite simple. In m3, it is a case of repeated root, so we will write down like c3, m3 power k plus c4 k. Remember I said is a repeated, you have to multiply it, m4 power k. Okay, so c3, m3, m4, this thing. Okay, c4. Now keep in mind I cannot use c1, c2 again, because c1 is this one, c2 is this one, c3, c4. So you just need to do the process and add all of them. Now this is a complex. So how do we write down the complex? The process is quite simple. I just explained to you. c4 is used. Now c5. c5 is 2 plus 3 iota k, and plus c6, 2 minus 3 iota k. So this would be your answer. Just replace the values 1, 2, 3, 4, whatever in place of m1, m2, m3, m4, m5, m6. You will get the final answer. So this is the process. So what's the key point? Key point is just repeat the individual process as you have learned in the case of this sequence. Okay. And so this process is called superposition. So what we are doing, we have a possibility of a roots from repeated, not repeated, or a complex. So what we are doing, we are constructing a solution by positioning them. That is, we are connecting them like that. Okay, this is the process. So student, let's end there, and I will give you a few examples to discuss in the live session so that you can try them. In fact, I will add them in a Google Classroom as well, so that if you learn those examples, you can practice to find the roots. It's not a rocket science. Just you know to know the order, type of the difference equation, and reason to construct the difference equation. This is the main part. And solution strategy means you have to find a formula that will generate that sequence. And how do we do that? Nothing. You just need to find a characteristic equation. This will give you the roots. And when you have a roots, you can have a repeated root, distant root, or complex. You just need to write down the solution accordingly. So whenever you write down the solution, you will get some constant c1, c2, c3, and so that based on the order. What does this represent? C1, C2, C3 are the unknowns, and if we want to make our solution particular solution that is specifically to the certain condition, we need to impose conditions to get C1, C2, C3 value.